So, Alberto and I, we are here to tell you more about the programs that we are offering. The fact that you are here, that means that you have passion and love towards physics and mathematics, and we have some programs to offer. So on my end, I'm an assistant professor from the Department of Mathematics, and we have 4 major that I would like to introduce. The most popular one is the actuarial science major, which is actually a shared major with the School of Business. So actuarial science, what does that do? You may have heard the word. Actuarial scientists, they do work with risk management, so at banks and insurance companies. It's a very good job, but it's a very hard major to follow because in addition to your major, you have to pass certain qualifying exams to become a fully fledged actuarial scientist. There is a student club where you can talk to people from the same program a couple of years ahead of you, and they will help you, guide you. And there is a very good student community there. Otherwise, we have an applied statistics major. Statistics, they deal with big data. You may have heard the word big data popping up here and there. Think about the fact when you finish your favorite show on Netflix and then you see suggestions on what else to watch, or when you buy a product on Amazon and you see suggestions. That's all based on big data. Then we also have mathematics majors, which will give you a wide overview of different topics in mathematics. And after that, if you apply for a job, companies will appreciate that you have a wide understanding and you have a mathematical point of view. I myself have a math major, and with that major, I worked with engineers for a couple of years before my graduate studies, and I really enjoyed it, and it was beneficial both for them, both for me. We learned a lot from each other. I ended up in a completely different environment, and I had managed just nicely. And last but not least, we have the secondary education major. And if you're here for the secondary education major, either in math or physics, we should say thank you so much for your interest. Because if you show your passion to your student, the same passion you have received from your high school student, that means that we are going to be here in 5 years, 10 years, 15 years for another Go for the Code, because the students you will inspire will come and see these sections. And that's all on my end for about the math majors. We have minors also, but the minors can be matched to the majors one by one. We have a liberal arts math minor, we have a statistics minor, we have a secondary education minor. They match very nicely with the major. And that's all on my end. So Alberto, please go on.
Sure. I'm Alberto Rojo. I'm also on the faculty. I'm a professor in the physics department. I do theory of physics, and I really like what I do. I'm a researcher in theoretical physics. I don't know if you're familiar with the research in physics. We divide ourselves in 2 broad groups: the people who do theory, like myself, and that usually it's pen and paper and computer. And then the experimentalists who go to the lab and do the real experiments. I'm on the theory side of things, but I really like to tinker. I like to experiment with things, and I started a series during the pandemic that we had to stay home. I started a series of videos explaining everyday phenomena with experiments that you could do with the things that you could buy at the hardware store or you can find at home. So our physics department is relatively small. We have about 10 faculty members, but we're pretty strong in terms of research. We're strongly funded. We do very nice research on our department, and we offer, as well as Thomas was saying, we offer at the graduate level, we have the PhD physics in computational physics and the PhD in program in medical physics. On top of that, we have undergrads, and the undergrads are involved in research. So I want to show you a couple of slides that I prepared for. So I just prepared a few slides that show one of the things that people are usually interested is in what is the salary, right, for typical salary for the range. And this has some time. This is 2016. It might have improved a little bit. So you see that we beat mathematics, not the actuarial sciences, of course, but no, I'm just kidding. So it's a good salary range, and there's lots of jobs that you can get with a major in physics, because physics trains you to think logically, to solve problems, to formulate questions in such a way that they have answers, and that is a skill that that is appreciated, but not only if you want to become a physicist professionally, a researcher, or even a high school teacher. It helps you if you want to work in different fields of knowledge and different jobs that require that technical ability that are not necessarily physics per se. For example, when I was this is for the graduate school, but it applies as well for undergraduates. When I was a postdoc at the University of Chicago, we were 5 postdocs. That was a long time ago, but we were 5 postdocs, and 2 of us stayed in academia, and the other 3 went to banking or consulting. And they have much larger offices than I have now. I don't know if they're happier, but they're definitely richer. And so there are a lot of jobs that it could be on defense or in defense industry. It could be on auto industry, in which you will do some technical work, even in management, that or even in consulting companies. For example, McKinsey and Company hires physicists, and they start doing jobs that are evaluating the profitability of a company, and you're not necessarily using the equations that you'll learn, but the method is crucial. The scientific method, the logical approach of a problem. And so this is again, a salary range for the private sector and different fields which you can go, and the salary range. I used to be the advisor for high school teachers, which is we have a program, a minor and a major, and that's jointly with the education department, where you're trained to be a high school teacher, which is, I think, a very valuable line of work that you could pursue after getting a degree in physics. I took this slide from a different talk that we give to incoming students. Of course, this is a picture from when I was an assistant professor like Thomas. I now have a lot of gray hair. I usually give advices to students that come in, and I give a list of 10 advices that some of them are corrections. It's like talking to myself. When you give advice, it's like you're talking to yourself in the past, you know? And it's like, say, for example, I said, do all of the end of chapter problems, learn what you need, focus, work, finish, publish is another advice I always give. And the one that I wanted to give you, and that it will apply even if you decide to be a physics major or not. And I think it's a good advice. And it's of the list of 10, and I didn't write them here because this is not the purpose of this presentation, but it's the advice that my daughters, who is now a professor at Colorado, it's a favorite for her, and it's something like develop a tolerance to partial understanding. Right. So it was my experience when I started being interested in physics when I was in high school, that I read the articles. I was subscribed to Scientific American. I like to read articles about physics, and I got frustrated because I understood only the first paragraph, the introduction, and then as I went on, it was difficult to understand, and I stopped and left the article. And then when I became more mature and I saw my colleagues, or even more senior colleagues, that would grab a paper and they will skip the parts that you don't understand and keep going to the end, and they get a general idea. And that applies when you're studying anything. If you don't understand something, don't get frustrated. At the end, in the future, as you keep progressing and studying, those points of partial understanding will collapse and gradually develop an understanding. That's one of the advices that I give. And another one that is important, that I think it applies not only to physics majors, but to everyone: ask questions, talk to people, ask questions in seminars, and ask questions verbally every time you have an opportunity. There is no stupid question. The only stupid question is the one that is not asked. And it's not only, it's important in many respects. One is that you help the audience when you ask a question. And the other, for me, from the cognitive point of view, asking a question is the mind prepares to solve the problem involved in the question once you formulate it, right? Because it puts you in, it forces you to organize your idea, organize your doubt, and express it verbally. And an anecdote that I always tell is that it happened to me repeatedly that there's a problem that I can't solve. I'm working all the weekend. I'm trying to solve the problem. I can't solve it. And Monday morning, I knock the door of my colleague, usually David Garfinkel, who's a colleague of mine, and I start explaining the problem to David on the board. The moment I start explaining it, the answer comes, right? So it's not that you're going to always find the answer that way, but you will notice that once you ask the question, you've answered yourself part of it, because you realize things that you didn't realize before asking it. So those are random comments. I want to emphasize also that we do a lot of, we get involved with undergraduates in publishing papers. These are some of the papers published in our department with undergraduates, right? In a lot of papers that were published with Physical Review Letters. This is a journal that is very prestigious, and it involves undergraduates. So this is the breakout of our department. We have a biological and medical physics faculty. We have a gravitational physics faculty. They do research on black holes. And then there's the condensed matter physics, where the group where I belong. I have a longer description of what we do specifically on research, but I think that gives you an idea. We're strongly funded. We're very happy with the work. We're a very harmonious department, and we really like students. So, so I think that will be my quick spiel about how good our department is. It's not as good as the math department, of course, but it's almost.
So Hannah, if you're worried about the remote learning, no worries. We all worry about it. Still, even after 1 year, I don't think that we even have all the necessary skill sets. It's not the same as having an in-person class. But we are doing our best to reach out to students. We have the same setup with office hours, same setup with all the helps that we would give you in person. So we are trying the best. If your concerns were about the remote learning, no worries about that. We are trying our best to accommodate everybody and give you the same feeling as if we were in person. And hopefully it will be over at some point.
And I have hopes. I don't know if I'm speaking too much, but I have hopes that in the fall we're going to be all vaccinated, and we can. You don't think so, Thomas? Okay.
Sadly not. I wish, but sadly I don't think so.
All right, but in any case, yes, I've been working. It was a transformation for me to teach online. I teach a course that is a hands-on experiments with a lot of hands-on experiments, and it was quite a change. I had to prepare new material, but I also enjoy it because it's a new format, and you can, the office hours are easier to coordinate because you don't have to go to the office and be at the office. So there are a lot of resources that are also helpful, and my only complaint with this is that I'm not, it's also the case in this particular meeting. I don't see the faces most of the times. Exactly. And seeing the faces in the teaching process is crucial for me, right? Yep, because I know exactly. I like to see the faces, to see the reactions, see the nodding, see how they're try to sync my rhythm of my teaching rhythm with with the level of attention. So that's the thing that I would change. But of course, everyone's so it's an effort. It stresses me sometimes to be talking to a screen, right? And so that's your part. We'll do our best to teach you and to help you and to succeed. But you have to help us also teach you.